Okay, question 8 and question 9, the last two questions of exercise 1C. So the red question being advanced and yellow being more thought discussion. So question 8 says this: prove that n squared plus n plus 41 does not take prime values for all positive integers. Right, this one. Again, as I've always been saying, if you weren't sure where to begin, maybe choose a number just to kind of get it into your head what is going on with this. So let's just choose a value of n, okay, and we're trying to show that when you put a value of n into this, it isn't always prime. So let's just choose a value of n, okay, like n being equal to 1. And let's put it into our statement. So n squared, so 1 squared, plus n plus 1 plus 41, okay, which is equal to 1 squared, 1 plus 1, 2, which is equal to 43. And 43, it is a prime number. So unfortunately, right, I need to keep going. I haven't disproven anything yet. Let's keep going. Let's go for n equals to 2. Okay, so what's that going to be equal to? So 2 squared plus 2 plus 41. Well, 2 squared is 4 plus 2 is 6 plus 41 is equal to 47. 47 is another prime number. So not looking good so far. Okay, but we don't stop. We have to keep going. But maybe at this stage, we've got to start thinking a bit more craftily. So I've tried one, I've tried two, I've tried one odd, one even. Let's go for something like, I don't know, maybe n being equal to 10, and let's just see what happens. Okay, if n is equal to 10, what's going to happen? Well, we're going to get 10 squared plus 10 plus 41 being equal to 10 squared is 100 plus 10, 110 plus 41 is 151, 151, it is prime. So it isn't looking too good so far. Maybe at this stage I'll try one other number, like a prime number, like 3. Okay, see what happens. If n is equal to 3, what's going to happen there? So 3 squared plus 3 plus 41, so 9 plus 12 plus 41 is equal to 53. So 53 is unfortunately prime. Right, we're not looking too good so far. So I've tried a bunch of numbers there. I've tried 1, I've tried 2, so odd and even I've tried 10, because why not really? And n is equal to 3 is another prime number. But I haven't tried the number 41, and if I try the number 41 and put it in for n squared and n, I can factorize out 41, and that might be useful, okay? And maybe you're thinking, how did I know to think along those lines? It's just practice with these questions. You just spot them. Maybe it's wrong, but this is the way that we can do this. So, right, if n is equal to 41 with this question, we're going to get 41 squared plus n being 41 plus 41. Okay, and then with this, right, we can be a little bit crafty because 41 is in each of our 3 terms. Let's factorize out a 41. Okay, so if I take out a 41, so 41 bracket, so 41 times by another 41 will give me 41 squared, so 41 times 41. And then I've got a 41 and a 41, so I've got basically plus 1, because 41 times 1 is 41, plus another 1. There we go, good. I can rewrite this a little bit more simply because, right, 41 bracket 41 add 2 is equal to 43, okay, and there we go. Right, this number is not going to be a prime number because, right, well, 41 times 43, what does that equal to? 41 times by 43 is 1763, so 1763. Okay, if we just go and draw it over here, 1763. Well, what is the definition of a prime number? It has only 2 factors, which are the number 1 and the number itself, 1763. Okay, but I've shown down here that, well, 41 times by 43 are other factors. 41 times by 43 are some other factors of this number. Okay, so actually, when n is equal to 41, we get a number that is not prime, which is 1763. So I've disproven that statement with one example. Okay, and actually here you could use, thinking about it, any multiple of the number 41 and you would disprove the statement. Okay, so that's question number 8. Okay, so when n was equal to 41, but actually you could use any multiple of 41 and that would disprove this statement. So hopefully that was clear. It just comes with practice, this kind of thing. You won't probably, if I saw that when I was in school, I would have struggled with it, but it's practice. Okay, question number 9 is yellow, so a discussion-based question, and it says, are any 2 straight lines that never meet necessarily parallel? Right, so what it's talking about here, so any 2 straight lines that never meet, like this, necessarily parallel. If you think about it in 2 dimensions, well, then they are always going to be parallel. But what about in 3 dimensions, right? If you've got, hopefully you can see this on the camera, you've got to imagine, right, this arm here, this is one straight line, and this arm here is another straight line, okay? These never meet, okay? If I sort of turn my body around, right, they don't meet, okay? But they're not parallel. So actually, there is a case, right, in 3 dimensions, and we call these sort of lines, they're called skew lines, as you will see later on in the course. If you've got lines that are skew, they're straight lines that never meet, and they're not parallel. Okay, so to answer the question, are 2 straight lines that never meet necessarily parallel? No, they could be skew. So let's type it up because my handwriting isn't the best. So no, we could have skew lines in 3 dimensions. Okay, so just thinking a little bit outside the box with that one there. Okay, and that is it for exercise 1C. Hopefully that was useful. Any questions? Of course, you can comment. Thank you.